Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 6 video on the chapter of time and work, where I will solve the problems of assignment number 2 which was provided in the previous video. These problems are based on pipes and cistern. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel. And also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of assignment number 2 on pipes and cistern from the chapter of time and work. Okay, so I have written down all the problems of assignment number 2. There are 9 problems and all the problems are multiple choice questions where one choice will be correct. I hope you have watched all the previous videos, that is part 1 to part 5, based on the theoretical concepts, that is general rules and the rules of pipes and cisterns, and also the video where I solved the problems of exercise 13A and 13B. If you have not watched those videos, I strongly suggest that you please watch them first so that you have a good understanding of the chapter concepts. Okay, so let's start solving the problems. Tap A can completely fill an empty tank in X hours and tap B can empty the filled tank in Y hours. Okay, so tap A is an inlet and tap B is an outlet. Okay, if 1/4 of the empty tank is filled in Z hours, keeping both the taps open, then which of the following is true? So if 1/4 of the empty tank is filled in Z hours, okay, when both the tap A and B are working, that is when both A and B are working together. Okay, so first we need to find what is the work done in 1 hour by the tap A and B, and then we will add their work done, and we will find when both the taps A and B are open, what is the work done in 1 hour by A plus B, that is when both tap A and B are open. Since it is talking about it is given that 1/4 of the empty tank is filled in Z hours, it means that eventually the tank will be filled up, which means that the work done by A has to be more than work done by B. Okay. Now, so work done by A in 1 hour, we know from the first rule of pipes and cistern is that 1 by X, positive 1 by X, and work done by B in 1 hour will be negative of 1 by Y, because tap B is an outlet. It empties a tank, so the work done by an outlet is always negative. So we have this. Now, so work done. Now work done by A in 1 hour equals to 1x also means that in 1 hour 1 by x fraction of the tank is filled up by A alone, and the work done by B is equal to in 1 hour is equal to 1 by Y also means that in 1 hour the tap B alone can empty 1 by Y part of the tank. Okay, so work done by A plus B, that is when both the taps are working or both the taps are open, in 1 hour will be equal to 1 by X minus 1 by Y, which is equal to Y minus X divided by X Y. Okay, now it is given that if 1/4 of the empty tank is filled in Z hours, 1/4 of the empty tank is filled in Z hours, that is when both the tab A and B are open, the work done in Z hours is 1 by 4. Okay. Now, mm, so work done, we know that work done by A plus B in 1 hour is y minus x by x by xy. From here, we can say that work done by A plus B in Z hours by simple unitary method, we can say by Z hours will be Z into y minus x divided by x y. Because in 1 hour, if work done is something, let's say 1 hour the work done is W, then in Z hours the work done will be WZ. This is simple unitary method. So we have work done by A plus B in Z hours is Z into y minus x divided by xy. Now this work done must be equal to 1 by 4, since the problem is given in the problem that if 1/4 of the empty tank is filled in Z hours, this means that in Z hours, so this means that the work done in Z hours by both A and B is 1 by 4. So now we can say that Z, this is the work done by A plus B, that is when both the tabs A and B are open in Z hours. So we can say that Z multiplied by y minus x divided by xy should be equal to 1 by 4. Now the problem is asking then which of the following is true. So we have to find the relation between x, y and z. Okay. So first option A will not be correct, because you can see that y minus x divided by xy is equal to 1 by 4 z. So choice A is definitely not correct. Choice B 4z y minus 4z y minus I. So we have this relation. We got this relation or equation. From this, by doing cross multiplication, we will also get 4z multiplied by x minus y is equal to xy. So we can see that choice B is equal to the choice B is correct, because we know that this is the equation that we are getting, and from this equation, if we do cross multiplication, we see that the result we are getting is 4z multiplied by x minus y is equal to xy. So definitely choice B is the correct choice. Okay. Now I am not checking choice C and D, because I know that only one choice will be correct. Wait a minute. Choice. Oh, sorry. Not choice B is correct. Choice B is incorrect, because choice B is given 4z multiplied by y minus x. But actually the relation we got is this. This is the relation. So choice choice D is the correct choice. 4z multiplied by x minus y is equal to what I am doing. So we have this relation. Z into y minus x divided by xy is equal to 1 by 4. From here we get, if you do cross multiplication, we get 4z multiplied by y minus x is equal to xy. So we get this relation, and so definitely choice B is correct. D is not correct, because the choice D, it is x minus y, but the actual relation we get is 4z multiplied by y minus x is equal to xy. So the correct choice is B. B is the correct choice. Okay, let's do the next problem. Uh, Two inlets A and B can fill an empty tank in 5 hours and 10 hours respectively. Okay, so both are inlets. Okay, and outlet C can empty the filled tank in 15 hours. Okay, all three pipes A, B, and C are kept open for X hours in the empty tank. So the pipes are connected to an empty tank and both are open for X hour. I mean, all of the types pipes A, B, and C are open for X hours. Now, what is the value of X if 3 by 10th of the tank is still empty after X hours? Okay, so after in X hours, some part of the tank will be filled when all the pipes A, B, and C are working, and some part will be left empty. It is given that after X hours, that empty part is 3 by 10, which means that the remaining part was filled, that is 1 minus 3 by 10, which is 7 by 10th part of the tank is filled in X hours. Okay, so we have work done. Now, whenever I am writing that work done by A in 1 hour is equal to, it will be in this problem 1 by 5. Now, if it is confusing or hard for you to understand that work done by A in 1 hour is 1/5, you can consider it as 1/5 of the tank is filled by A alone in 1 hour. Similarly, if the work done by A in 1 hour is negative 1 by 5, then you will understand that it means that the tap A in 1 hour will empty 1/5 of the tank. Okay. So now we have, from the given information, we can say that work done by A in 1 hour is 1 by 5 because it is given that the pipe A can fill an empty tank in 5 hours. Similarly, work done by B in 1 hour will be, since B is also an inlet and it fills an empty tank in 10 hours, we can say work done by pipe B in 1 hour is 1 by 10. Now, C is an outlet and it empties a completely filled tank in 15 hours. So, we can say work done by C in 1 hour is equal to minus negative of 1 by 15, since C is an outlet. So, this implies we have to see what is the work done by all of them in 1 hour. So, work done by A plus B plus C in 1 hour will be equal to 1 by 5 plus 1 by 10 minus 1 by 15. The LCM will be 30. So 6 plus 3 minus 2 divided by 15. This is equal to 9. 7 by 15. So in 1 hour, work done by A plus B plus C in 1 hour is equal to 7 by 15. This means that when all the pipes A, B, and C are working together, or all the pipes A, B, and C are open, they are filling 7 by 15th part of the tank in 1 hour. So what part of the tank will be filled in X hours by all the pipes? Work done by A plus B plus C in X hours from unitary method, we can say, will be 7 by 15 multiplied by X. This is equal to 7x by 15. Part of the tank will be filled by all the three pipes in X hours. So this implies after X hours, part of the tank still empty. The whole tank is 1. The whole tank, we always consider the whole tank as 1. and we see that in x hours the work done by a plus b plus c is 7x by 15, which means that in x hours 7x by 15th part of the tank is filled. So definitely the part of the tank empty will be 1 minus 7x by 15. And in the problem it is given that after x hours 3 by 10th of the tank is still empty. So this means that 1 minus 7x by 15 is equal to 3 by 10. So this is a linear equation in x. We have to solve for x. So we have this is, we can say 7x by 15 will be equal to 1 minus 3 by 10, which is equal to 7 by 10. So this implies x will be equal to 15 by 7 multiplied by 7 by 10. Cancels out 3, 2, this is 3 by 2 hours, 3 by 2 hours, but it is not there in the choice. Let me check if I, let me see if I did the calculation correct or not. Work done by A is 1 by 5, work done by B is 1 by 10, work done by C is minus 1 by 15. Okay. So work done by A plus B plus C in 1 hour is 1 by 5 plus 1 by 10 minus 1 by 15. 5, 10, 15, denominators are 5, 10, 15, the LCM will be 30. So we have 6 plus 3 minus 2, 9 minus 2, 7 by 15. So work done by A plus B plus C in 1 hour is 7 by 15. So work done by A plus B plus C in x hours will be 7x by 15. So 7x by 15 is the part of the tank filled in x hours by all the three pipes. So then after x hours, the part of the tank which will be empty is 1 minus 7x by 15, which should be equal to 3 by 10. So we have to solve the equation 1 minus 7x by 15 is equal to 3 by 10. From here we get 7x by 15 is equal to 1 minus 3 by 10, which is equal to 7 by 10. So from here we get x is equal to 15 by 7 multiplied by 7 by 10. 3 by 2 hours is my answer, and it is not given in the choice. I think so most of these questions are framed by me, so I think I gave the wrong choices. My answer is coming out to be 3 by 2 hours, which is basically 1.5 hours. So this should be the answer. Now, if I am doing any calculation mistake and my answers are coming wrong, please do let me know in the comment section. I will highly appreciate that. Okay. Sorry, I could not match with any of the choices because I think my answer is correct, 3 by 2 hours, and I have by mistake incorrectly given the choices. Okay, let's see the next problem. Pipes A and B fills an empty tank in m hours and n hours respectively. In how much time a tank whose 1 by rth part is already filled will be completely filled by the pipes A and B if they are both open? Okay, so pipes A and B fills an empty tank in m hours and n hours respectively. So they are both inlets. So let's see work done by A in 1 hour is equal to 1 by m. Work done by B in 1 hour is equal to 1 by n. So this will imply work done by A plus B, that is when both the pipes A and B are open or both the pipes A and B are working, in 1 hour will be equal to 1 by M plus 1 by N, which is equal to M plus N divided by Mn. Okay, now it is saying that in how much time a tank whose 1 by Rth part is already filled will be completely filled by the pipes, which this means that, so 1 by Rth part of tank filled implies, if the tank is 1 by Rth filled, this implies that 1 minus 1 by R, the whole tank is 1. We always consider the whole tank or cistern as 1. So this means that 1 by 1 minus 1 by Rth part is empty, and this part we have to find how much time the pipe A and B will take to fill this part, that is 1 minus 1 by Rth part. Now this is 1 minus 1 by R is R minus 1 by R. Now if we know that the work done by A plus B in 1 hour is M plus N divided by Mn, and we need to find how much time it will take by A plus B to fill 1 by Rth part of the tank. So this implies time taken by A plus B to fill R minus 1 divided by R part will be equal to, sorry for my congested solution, I hope you are able to make it out, you are able to read it. So time taken by A plus B to fill R minus 1 by R part of the tank will be equal to will be equal to Mn divided by M plus N, this multiplied by R minus 1 by R. Now why is this so? If we know that now work done by A plus B in 1 hour is equal to M plus N divided by Mn, this means, so this we can write it as M plus N divided by Mn can be written as 1 by Mn divided by M plus N. Now if work done by A plus B in 1 hour is 1 by Mn divided by M plus N, this means that the whole tank will be filled by A plus B in Mn divided by M plus N. So if you know that the time taken to fill the whole tank is n hours, then the time taken to fill some 1 by Rth part will be 1 by R multiplied by N. So that is the formula I have applied. Time taken by A plus B to fill R minus 1 by R part will be equal to R minus 1 by R multiplied by the time it takes by A plus B to fill the complete tank, which will be Mn divided by M plus N. Now this is the required answer. Now we have to see which of the choices matches with this answer, that is Mn multiplied by R minus 1 divided by R into M plus N, and I think it is choice D. So D should be the correct answer. Choice D is the correct answer. Okay, let's do problem number 4. Pipe A fills 1/4 of a tank in X hours and pipe B empties 1/3 of the tank in Y hours. If both pipes A and B, when open, can eventually fill the empty tank in certain amount of hours, then which of the following must hold? Okay. Uh, so let's see. It is given that so pipe A fills 1/4 of a tank in X hours means that uh, A in X hours. This means that work done uh, you can so work done by A in X hours is equal to 1 by 4. The pipe A fills 1/4 of a tank in X hours means that in X hours the work done by A is 1 by 4. So from here we can say that work done by A in 1 hour is equal to 1 by 4x. 1 by 4x using simple unitary method. If work done by A in X hours is 1 by 4, then work done by A in 1 hour will be 1 by 4 divided by x, which is 1 by 4x. So similarly we can say that work done by B, it is given in y hours. Now pipe B empties 1/3 of the tank, so pipe B is an outlet, so the work done by B will be negative. So it is given that work done by B in y hours is equal to 1/3, so it will be minus 1 by 3. It is given that pipe B empties 1/3 of the tank in y hours. This means since it empties, pipe B is an outlet and the work done by an outlet is always negative. So we can say that the work done by pipe B in y hours is minus 1 by 3. So we can say work done by B in 1 hour by using simple unitary method will be minus 1 by 3y. Now if both the pipe A and B are open and if per hour the tank is being filled, then the work done by A has to be greater than the work done by B in 1 hour. It is saying that if both pipes A and B when open can eventually fill the empty tank in certain amount of hours. So if when A and B both open uh, work done by A plus B in 1 hour will be equal to 1 by 4x minus 1 by 3y. Now we must know that if tank eventually gets filled up, if both the taps A and pipes A and B are open and if the tank eventually gets filled up, this means that per hour the tank is being filled. So if tank eventually gets filled up, this will imply definitely that work done by A plus B in 1 hour must be positive. Only then must be positive. Only then when the work done per hour is positive, only then we know that the tank will the tank is filling up per hour, and if the work done in per hour is negative, this means that the per hour the tank is being emptied. Since in the problem it is given that when both pipes A and B are open, eventually the tank gets filled up. This means that per hour the tank is being filled up, with which also means that per hour the work done by A and B is positive. So this implies then we must have 1 by 4x minus 1 by 3y must be greater than 0. That is 1 by 4x minus 1 by 3y must be positive. So this means from here we can say that 1 by 4x must be greater than 1 by 3y. Now if we have 1 by 4x greater than 1 by 3y, remember that x and y, they are positive. So pipe A fills 1/4 of a tank in x hours. This x, and the pipe B empties 1/3 of the tank in y hours. X and y are always positive. So time taken are never given in negative. Time taken are always positive. So we have x and y are positive. So 4x and 3y are also positive. Uh, Now 4x is greater than 0 since x is positive. Also we know that 3y is greater than 0. So if 4x is greater than 0 and 3y is greater than 0 and we have 1 by 4x greater than 1 by 3y, then we can say that the reciprocal, then we can say that the reciprocal of 1 by 4x, that is 1 by 4x must be less than the reciprocal of 1 by 3y, that is 1 by 3y. The concept is that okay, so now this implies now 1 by the reciprocal of 1 by 4x is 4x. So we have 4x less than 3y. So this is the relation we must have between x and y. 4x must be less than 3y. So the correct choice is D. Now we use the fact that please remember that if A and B are two numbers which are positive and we have 1 by A is greater than 1 by B, then always their reciprocals, if you take the reciprocals, the inequality, that is greater than sign, will become less than sign. So then this will imply that A is less than B. Okay, so the correct relation is 4x less than 3y. So the concept used in this problem was that if two pipes are working together where one pipe is an inlet and other pipe is a outlet, and if they are connected to a tank and the tank is initially empty and they are open, and if the tank eventually gets filled up by water, this means that per hour the work done by A plus B has to be positive. Only then per hour the tank is being filled up by some water. If it is negative, then the tank will never be filled up. Okay, let's see the next problem. Problem number 5 says taps A and B, when both open, fills an empty tank in 4 hours. Fills an empty tank in 4 hours. Okay, so and tap A alone can fill the empty tank in 2 hours. So tap A alone can fill the empty tank in 2 hours. This means that tap A is an inlet, but nothing is said about the tap B. It is only given that taps A and B, when both open, fills an empty tank in 4 hours. Now, tap B can be an inlet and it can also be an outlet. So both, possibility is both. There is tab B, the possibility of tab B, it can be that it can be an inlet and it can also be an outlet. But the actual type of tab B we have to find from the given fact. Now it is given, we know that tap A alone can fill the empty tank in 2 hours. Okay, so we know that work done. Now from the given fact, we can easily find the work done by B alone in 1 hour. So from that fact, we have to identify whether type B is an inlet or outlet. If the work done by B in 1 hour is positive, then B will be an inlet, and if the work done by B is coming out to be negative in 1 hour, then type B will be an outlet. So we have to find what is the work done by type B in 1 hour. So work done by A in 1 hour is equal to 1 by 4. And we don't know about anything about B, but we know that uh, work done by A plus B in 1 hour is equal to 1 by 2, since it is given that no sorry no oh sorry work done by A in 1 hour is 1 by 2. This will be 1 by 2, and the work done by A plus B, that is when both the taps A and B are working or both the taps A and B are open, then the work done by the taps A and B together is 1 by 4, because it is given that taps A and B when both open fills an empty tank in 4 hours. So the work done will be 1 by 4 by A plus B in 1 hour. From here we can easily say now work done by A plus B is equal to work done by A in 1 hour plus work done by B in 1 hour. Work done by A plus B means work done by A and work done by B. So we have work done by A in 1 hour plus work done by B in 1 hour is equal to 1 by 4. Now we know that work done by A in 1 hour is half. So we have half plus work done by B in 1 hour is equal to 1 by 4. So this implies that work done by B in 1 hour will be equal to 1 by 4 minus half, and this is equal to minus 1 by 4. So we can see that the work done by B in 1 hour is negative, is coming out to be minus 1 by 4. So definitely pi B is a tap, B is an outlet. And also we can see that the work done by the pipe B in 1 hour is minus 1 by 4, which means that 1/4 of the tank is emptied by tap B in 1 hour, 1/4. So clearly the choice will be choice D. It is asking then which of the following is correct about tap B. So tap B is an outlet that empties 1/4 of the tank in 1 hour. So choice D is the correct choice. Okay, let's do problem number 6. An inlet A is twice as fast as an outlet B. If B can empty a filled tank in 10 hours, then time taken by A to fill 3/4 of the tank is how many hours? Now, the important information given in this problem is, or the confusing or the tricky information is, an inlet A is twice as fast as an outlet B. Now, when it is said, what does it mean? It means that the time taken by B, since B is an outlet, the time taken, you can consider it like this, that the time taken by B to empty a filled tank will be twice as the time taken by A to completely fill an empty tank. This information, that an inlet A is twice as fast as an outlet, you can consider, the meaning of this, you can say that time taken time taken by B to empty a filled tank is equal to 2 times the time taken by A to fill the empty tank. So this is what it means when it says an inlet A is twice as fast as an outlet B. That is the time taken. Definitely, A will take half the time as B to fill the empty tank. Where compared to if X is the time taken by B to completely empty a tank, then X by 2 will be the time taken by A to completely fill an empty tank. Okay. So now it is given that B can empty a filled tank in 10 hours. Now B can empty a filled tank in 10 hours will imply, since A is twice as fast as B, will imply A can fill an empty tank in 10 by 2 or 5 hours. 5 hours. Okay, so now in 5 hours. So now we know that A can fill an empty tank in 5 hours. Now it is asking how much time it will take by the tap A to fill 3/4 of the tank. 3/4 of the tank. Mm, so this will imply that time taken by A to fill 3/4 of tank will be equal to 3 by 4 multiplied by 5 hours, because from the fact that if the pipe A fills an empty tank completely in 5 hours, then the time taken by A to fill 3/4 of the tank will be equal to 3 by 4 multiplied by 5. This is a concept or formula you must always remember. That is, if it is given that so if pipe A can fill an empty tank in n hours, then P by Q part of the tank will be filled by A in P by Q multiplied by n hours. So this is equal to 15 by 4 hours, which is equal to 3 and 3 by 4 hours, which is equal to so this is 3 and 3 by 4 hours. Now you can always convert it as hours and minutes. I am not doing that. Okay, let's do the next problem. Problem number 7. Tap A fills an empty tank in X hours and tap B empties the filled tank in X by 3 hours. Okay. Both the taps are opened for X by 8 hours in the completely filled tank. Okay, so the tank is completely filled and both the tap A and B are opened, and where tap B is a outlet and tap A is an inlet. Then it is asking after which so after X by 8 hours tap A is closed. Both the taps are open for X by 8 hours in the completely filled tank, after which the tap A is closed. The remaining water in the tank will be emptied by tap B in how many hours? Okay. Since the tank was initially completely filled, then definitely per hour the water is being emptied. Water must be emptied. That is, the work done by A must be less than the work done by B. So let's see. Uh, mm, work done by A is given to be, it is given that tap A fills an empty tank in X hours. So work done by A in 1 hour should be equal to 1 by X. Work done by B in 1 hour, it is given that tap B empties the filled tank in X by 3 hours. So this means that work done by B in 1 hour is minus, since B is an outlet, it should be minus 3 by X, minus 3 by X, that is 1 by reciprocal of X by 3, reciprocal of X by 3, which is 3 by X, and it will be negative since tab B is an outlet. So this implies work done by A plus B, that is when both the tabs A and B are open, the work done in 1 hour should be 1 by X minus 3 by X, which is equal to minus 2 by X. So it's a negative. Work done per hour is negative. So definitely if the tank is initially filled, it will eventually be per hour, it will be emptied by A and B. Okay, so we see that work done by A plus B in 1 hour is minus 2 by X. So we need to find, or you can understand this statement as 2 by X part, 2 by X part of the tank is being emptied by A plus B in 1 hour. So, now the tap A and B was opened for X by 8 hours. So work done, we have to see how much work done, what is the work done by A plus B in X by 8 hours. In X by 8 hours will be equal to simple unitary method minus 2 by X multiplied by X by 8, which is equal to minus 1 by 4. So the work done, so when the pipes A and B are opened for X by 8 hours, the total work done by the two pipes is minus 1 by 4, which means that it is negative. So work done is negative, which means negative means some part of the tank has been emptied. In this case, the work done is negative by 1 by 4, which means that 1 by 4th part of the tank has been emptied by A and B in X by 8 hours. Okay, so this implies that part of tank emptied by A plus B in X by 8 hours is equal to 1 by 4. So this implies part of tank still filled, that is the part of the tank which is still filled with water, will be equal to 1 minus 1 by 4, since the whole part is 1. This is equal to 3 by 4. So 3 by 4th part of the tank is still filled with water, and this has to be emptied by the tank tab B, and it is asking the remaining water in the tank. The remaining water means in this problem 3 by 4th part of the tank. So the remaining water in the tank will be emptied by tap in how many hours? So this implies that 3 by 4th part of tank will be emptied by B in, we know that if the work done by B in 1 hour is work done by B in 1 hour is, we know that negative of 3 by X, negative of 3 by X, that is in 1 hour 3 by X part of the tank is being emptied by B, and we have to now find how much time it will take to M by B to empty 3 by 4th part of the tank. So this will be uh, mm, this is equal to, actually my negative of 3 by x means negative of 1 by x by 3. So we know that in x by 3 hours tab B completely empties a filled tank. X by 3 hours completely empties a filled tank, and so the time taken by tab B to empty 3 by 4th part will be 3 by 4 multiplied by x by 3, which is equal to x by 4 hours. So the answer is x by 4 hours. Okay, let's do problem number 8. Work done by a tap when opened for 4 minutes is 1 by 5. Work done by a tap when opened for 4 hours is 1 by 5. So it is given, okay. Then time taken to fill half of the tank by the tap is, okay. So it is given that work done by a tap, okay. So it is given work done by tap in 4 minutes. Now since the unit is given in minutes, we have to consider the work done per minute. So work done by tap in 4 minutes is equal to given to be 1 by 5. This essentially means that 1/5 of the tank is, since the work done is positive, it is given positive 1 by 5. It means that 1/5 of the tank is being filled by the tap in 4 minutes. So work done by tap in 1 minute will be equal to 1 by 5 multiplied by 4, that is 1 by 5 divided by 4, which is equal to 1 by 20. So work done by the tap in 1 minute is 1 by 20, which means that 1 by 20th part of the tank is being filled by the tap in 1 minute. If you know this, we can say from the general rule of a inlet tap that we can say that one part, that is whole tank or one part is filled by tap in 20 minutes. So if you know that if a tap in 1 minute does the work of 1 by 20, which means that 1 by 20th part of the tank is filled in 1 minute, this also means that to fill the whole tank it will take 20 minutes. So the whole tank means one part. So we are writing one part is filled by tap in 20 minutes. So using unitary method, we can say that how it is asking the time taken to fill half of the tank by the tap. Half of the tank means half part. So half part is filled by tap in 20 multiplied by 2, which is equal to 10 minutes. Now from the fact that we have found that in 1 minute when we have found that one part is filled by the tap in 20 minutes, obviously the half part of the tank will be obviously filled in a half of the time of 20 minutes, which is 10 minutes. So the answer is 10 minutes. Okay, let's do problem number 9. This is the last problem. An inlet with a leak at the bottom takes X hours to fill an empty tank. An inlet with a leak at the bottom takes X hours to fill an empty tank. Without the leak, it takes Y hours. Y is less than X. That is, it takes if the leak was not there, then the inlet is taking less amount of time. That is Y hours to fill the empty tank. So basically, this means that the leak at the bottom is acting as an outlet. So an outlet, and definitely that outlet is doing some work in per hour. That is, some water is being leaked. Some part of the tank is being leaked, and that part of the tank which is being leaked by the leak in 1 hour is the work done by the leak in 1 hour. Okay. Now it is asking the time taken by the leak alone to empty a filled tank. Now to know the time taken, to find the time taken by the leak alone to empty a filled tank, we need to first find what is the work done by the leak in 1 hour. Obviously that will be negative. Okay. Now it is given that without the leak it takes y hours to fill the empty tank. That is, if the leak was not there, then the inlet is taking y hours to fill the empty tank. So we can say that so let's say let inlet be A and the leak be B. So now we can say that work done by A in 1 hour is equal to so now we can say that the time taken by A to fill the empty tank is y hours, because it is given in the problem without the leak it takes y hours to fill the empty tank. So we can say since we are considering the inlet to be A and the leak to be B, that is A is the inlet without the leak and the leak we are considering to be B. Not we are naming the leak to be B and we are naming the inlet without the leak to be A. So now we can say the work done by A in 1 hour is equal to 1 by Y. Also work done by B, which is the leak, in 1 hour will be equal to will be no we have to find the work done by the leak B in 1 hour. We have to find it. Now the fact that an inlet with the leak at the bottom takes x hours to fill an empty tank, we can say that work done by A plus B, that is the inlet with the leak at the bottom, in 1 hour it will be equal to 1 by x. Since it is given an inlet with a leak at the bottom takes x hours to fill the empty tank, that is when there is a leak, the inlet is that is the leak and the inlet working together means A and B are working together. So the work done by A plus B in 1 hour will be 1 by x. Since it is given that the inlet with the leak at the bottom takes x hours to fill the empty tank. Now 1 by x it will be positive since it is filling the empty tank. We have this. Okay, now this implies work done by A in 1 hour. The work done by A plus B in 1 hour means work done by A in 1 hour plus work done by B in 1 hour. So work done by B in 1 hour is equal to, we are having 1 by x. Now work done by A in 1 hour we know is 1 by y. So we have 1 by y plus work done by B in 1 hour is equal to 1 by x. So this implies now we can find what is work done by B means the leak, in 1 hour will be equal to 1 by x minus 1 by y, which is equal to y minus x divided by x y. So this is the work done by the leak in 1 hour. Now the question is asking the time taken by the leak alone to empty a filled tank. Now if we know that the work done by leak in 1 hour is y minus x divided by xy, you can write it as 1 by xy divided by 1 minus x. That is, if we know that the work done by a pipe in 1 hour is 1 by n, where n is positive, then we can say that the pipe will take n hours to completely fill the tank. So we can say that now. Uh, Now B is a leak. Remember that B is a leak. Its work done will be negative. Its work done will be negative. So why it will be negative? It will be negative. See, the work done by B in 1 hour is y minus x divided by xy. Now x and y are positive, but y is given to be less than x. It is given that without the leak it takes y, which is less than x. So definitely y is less than x, then y minus x will be negative. So we can write it as this as negative of x minus y divided by xy. So we can write it as this as the work done by B to be uh, negative of 1 by xy divided by x minus y. So if we have this, so we are having work done by B in 1 hour is negative of 1 by xy divided by x minus 1, which means that this means that 1 by uh, 1 by xy divided by x minus y, this part of the tank is being emptied by the leak in 1 hour. So now we can say that time taken by B or the leak uh, to empty the filled tank, that is completely empty, completely filled tank should be equal to x by xy divided by x minus y, this many hours. So this is the answer, xy divided by x minus y is the answers. So this brings to an end in solving the problems of exercise 9 problems of exercise of assignment number 2. I hope this solving these problems will give you a better idea of how to solve the various kinds of problems and how to apply the fundamental concepts of the working principles of pipes and cisterns, and the concepts of work done, positive work done, negative work done, and the two general rules of that is the rule of an inlet pipe and the rule of an outlet pipe. Now, um, uh, as I always say, that after solving a set of problems, you must always recall the concepts and the write down or recall the concepts and the formulas used to solve the problems. This will give you uh, a regular revision of the chapter concepts. Now, um, a lot of concepts was used in solving these problems, that is the problems of assignment number 2. uh, Let me quickly uh, recall the concepts. This is very important, you must always do this, very important. That is recalling or revising the concepts and the formulas that was used to solve the problems. Very important. Recalling the concepts and formulas used. Uh, I'm listing down all the concepts. The first is that uh, if if work done, if work done, this is all related to pipes and a tank being pipes, and the pipe could be inlet pipe, the pipe could be an outlet, it could be an inlet, the work done could be positive, negative, and the tank is being filled or emptied. So if work done in 1 hour, the work done in 1 hour is 1 by n, where n is positive, and this implies that uh, uh, tank is being filled up, that is the tank is being completely filled, that is an empty tank is being filled up. This should be empty. This means that an empty tank is being filled up in n hours. If we know that the work done in 1 hour is 1 by n, where n is a positive, then we can say that since it is positive, this means that in 1 hour the tank is being filled up. That is 1 by nth part of the tank is being filled in 1 hour. So we can say that the whole tank will be the whole tank, that is the whole of an empty tank will be filled up in n hours. Okay. The next concept is that similarly, if work done in 1 hour is negative, negative for 1 by n, where n is a positive, this means that uh, a filled tank, that is completely a filled tank is emptied, that is completely emptied in n hours. Or you can also the meaning of this is that the meaning of the that work done in 1 hour is minus 1 by n, means that 1 by nth part of the tank is being emptied in 1 hour, and so this also means that the whole tank will be emptied in n hours. The next concept is if uh, a tank is filled up in x hours by 1 pipe, 2 pipe, 3 pipes, that does not matter. If a tank is filled up, if an empty tank is filled up, means it's completely filled up by water in x hours, this implies that time taken to fill p by qth part of the tank will be equal to p by q multiplied by x hours. Similarly, we can say that for emptied, that is, if a completely filled tank is emptied in y hours, then we can say that time taken to empty the tank, to empty the filled tank, that is, if the tank is filled, then the time taken to empty the filled tank, to fill sorry time taken to empty P by qth part of the tank, it will be equal to P by Q multiplied by X multiplied by Y hours. So if you know that if a filled tank is being completely emptied in Y hours, then we can say that time taken to empty P by Qth part of the tank is P by Q multiplied by Y hours. I think these are the main concepts that has been thoroughly used and applied, and also that if there are multiple taps open, if there are multiple taps or pipes working, then the work done by all of them in 1 hour is the sum of the work done in 1 hour by the individual pipes. So these are the main concepts. Okay, so I hope this video was beneficial. The solution of the problems of assignment 2 will give you a better idea to understand how to approach in solving the problems of pipes and cisterns, and how to apply the fundamental concepts of the inlet pipe, outlet pipe, the work done by an inlet pipe in 1 hour, the work done by an outlet pipe in 1 hour, and that the whole tank is be considered as one, and also the work done by an inlet pipe is positive and the work done by an outlet pipe is negative. All these concepts, how we are applying to solve the problems, you will get a better idea. So if this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will solve the problems from the exercise. I think it is the MCQ problems, that is exercise 13B from the textbook of author R.S. Aggarwal. There are 17 MCQ problems, and after this exercise 13B, I will solve the test paper 13, which is also based on the entire chapter of time and work. So please stay tuned for these two videos upcoming on the chapter of time and work. That will bring an end to the chapter of time and work, but also I will keep on solving 10 good problems on this chapter of time and work in the other playlist, that is Maths 8 Hot. So also keep an eye in that playlist. So I will end the video here. Thanks for watching, and until the next video, take care and bye.